Let's talk about one of the biggest headaches in all of software engineering, coordinating a distributed system. I mean, when you've got servers scattered all over the place, how in the world do you get them all to work together like they're one single machine? We're going to break down this classic problem.
Seriously, just think about that for a second. If you have a whole fleet of servers, how do they decide which one gets to be the boss? Or how do they all get the exact same crucial update at the exact same time? This isn't just a small problem. It's the fundamental challenge of what we call distributed consensus.
Okay, let's make this super concrete with a chat app. When you have just one server, life is easy. Alice connects, Bob connects, they're on the same machine, messages just fly back and forth. It's simple. But the second you need to scale up to handle more users, you add more servers and bam! You hit a wall. If Alice is on server A and Bob is on server B, how does Alice's server even know where to send her message? Suddenly, it's total chaos.
And we're not just talking about a few lost messages here. This kind of chaos leads to really nasty problems, like data inconsistency, where one server thinks one thing and another server has completely different information. You get race conditions, and eventually, you get catastrophic system failures. This is the exact pain point that engineers have been wrestling with for decades.
And that brings us to the hero of our story today. To wrangle all this chaos, a really clever tool was invented. Its entire job is to be the single source of truth, the conductor for this messy orchestra of servers. And its name? Apache ZooKeeper.
So that's the official, the textbook definition. ZooKeeper is this specialized, centralized service that's built to handle all those tricky coordination jobs. But what does that actually mean? How does it work?
Okay, this is the key. This is the analogy you need to hold on to. Forget all the complicated jargon for a minute. At its absolute core, you can just think of ZooKeeper as a very simple but ultra-reliable file system that all of your servers can see and use. It has folders, it has files, just like on your computer, but with a few superpowers thrown in.
So this whole magic file system idea is built on just three really simple concepts. First, you've got the hierarchical namespace, which is just a fancy way of saying the folder structure. The things that look like files are called Z nodes, and they just hold tiny bits of data. And then number three, and this is where the real magic happens, servers can put watches on any of those Z nodes and get notified instantly if the data inside ever changes.
Now, believe it or not, with just those three simple building blocks, ZooKeeper can solve some incredibly complex puzzles in the world of distributed systems. Let's look at a couple of the most common ones.
All right, first up, leader election. In a lot of systems, you need one server to be the boss, the leader, to call the shots for all the others. But what happens if that leader server crashes? How do all the other servers agree on a new leader without starting a digital civil war?
The way ZooKeeper solves this is it's beautiful. Imagine there's a Z node called /leader. All the servers who want to be leader try to create that exact same Z node at the exact same time. It's a race, but because of ZooKeeper's strict guarantees, only one of them will actually succeed. And just like that, you have your new leader. So what about the others? Well, the ones that failed simply put a watch on that /leader Z node. If the leader server ever crashes, its connection to ZooKeeper times out. That /leader Z node poofs out of existence, and that instantly triggers all the waiting servers to try the race again. A new election just happens all on its own.
Okay, on to the next puzzle. Let's say you have 1,000 servers, and you need to push a critical configuration update to every single one of them right now. How do you do that without creating a total mess where some servers have the old config and some have the new one?
And again, the solution is just so simple and elegant. You just store all your configuration data in one single Z node. Let's call it /config. Then every single one of your servers puts a watch on that Z node. When you, the administrator, need to push an update, you just change the data inside /config. And instantly, ZooKeeper sends out a notification to all 1,000 servers, and they all pull down the new configuration. Just like that, problem solved. No more stale configs.
So by now you might be thinking, okay, this sounds pretty great, but ZooKeeper's been around for a while, right? Is this something people are actually still using, or is this just a cool history lesson? Let's take a look.
Well, ZooKeeper first showed up way back in 2008, and it quickly became the absolute backbone for massive projects you've definitely heard of, like Hadoop and Kafka. It was the thing you used to manage those huge clusters. And while it's true that a lot of newer alternatives have popped up, ZooKeeper's DNA is so deeply embedded in so much critical infrastructure that it's still incredibly important today.
So the key thing to understand here is the trade-offs.
ZooKeeper is battle-tested, it's rock-solid, and it gives you incredibly strong guarantees about your data being consistent. That's why it's trusted for these foundational, can't-fail tasks. A lot of modern tools might be a bit easier to get up and running in a cloud-native world like Kubernetes, but they often make different choices, different trade-offs when it comes to those consistency models.
And this leads us to the big, practical question. If you were designing a new system right now, in today's world, when would it actually be the right call to reach for ZooKeeper?
This table really shows where ZooKeeper still shines. Think about something like a durable distributed lock. That's a situation where you absolutely positively cannot have two different processes touching the same resource at the same time. ZooKeeper's strong consistency makes it perfect for that. And that's the same reason it's still so trusted for those fundamental infrastructure jobs like service discovery or managing the routing tables in really massive, complex systems.
Okay, so we've seen what it is, we've seen where it's used, but let's zoom all the way out. Why should you, as someone who's into system design, really care about ZooKeeper even if you never end up deploying it yourself?
This right here. This is the single most important takeaway from this entire explainer. The patterns that ZooKeeper uses for leader election, for configuration, for distributed locks, these are fundamental concepts. Learning ZooKeeper isn't just learning a tool, it's like learning a blueprint for how to solve an entire class of really hard problems.
So even if you end up using a completely different tool down the line, the mental models you build from understanding ZooKeeper, this idea of a central service for consensus, of Z-nodes, of watches, those are going to be invaluable. I promise you, you will see these patterns pop up over and over and over again in system design.
And that's the thought I really want to leave you with. Take a look at the systems you're working on, or the ones you're studying. Where are those hidden coordination problems lurking? How are they being solved right now? Because really understanding that, that's the first step to building truly robust and reliable systems.